Hello. So this is a video addressing Young's rule and Clark's rule and how to work these formulas. So I have the formulas written on the board here behind me. They are somewhat abbreviated compared to what they are in the textbook. So Young's rule can be found at the bottom right-hand side of textbook page 635. Young's rule, that's what the Y stands for, right? Y for Young. And the reason, the way that I personally help myself remember the difference between these two formulas, Young, we're talking about age, right? We're going to use that individual's age noted in years. And the formula calls for us to place that age in years over the age in years. We're going to add it to 12. We'll get the sum. So it'll be age divided by the sum. And then we're going to multiply that by the average adult dose. And then over at the top left of textbook page 636, we have Clark's rule. C for Clark's rule. Clark's rule is based on the patient's weight, and this weight needs to be expressed in pounds. And our formula says to divide that weight in pounds by the number 150. It's just part of the formula. And then we're going to divide that answer by the average adult dose. Now, when I talk about, let me give you an example. If you look at example 37.1 on textbook page 636, they give us a scenario there of a child that needs to receive a medication that has a suggested adult dose of 650 milligrams, tells us that the child is 5 years old and weighs 44 pounds. What would be the dose using Young's rule is the actual question there. Do apologize, I had to grab my calculator. So Young's rule, using the child's age. And our scenario told us that we have a 5-year-old, right? So we're going to take that 5 and then underneath, I do apologize, I should have had brackets there. So we're going to take that age again, still expressed as years. We're going to add that to 12. I personally am a very visual person when it comes to math. I like to go ahead and put what it equals so that I know what number I actually divided by. And then we're going to multiply that by the average adult dose, which in this case is 650 milligrams. So that's how you would set your formula up. However, when you get ready to plug it into your calculator, the point I really wanted to express here is you're literally going to put in the number 5. You'll hit your divide key. We're going to use the sum here. So 5 divide 17. I'm not going to hit equals. I'm going to hit times because that's the next thing my formula calls for. I'm going to punch in that 650 milligrams and then I'll hit equals. And it should give you 191.176. 191.176. Yes. So when you're doing math with me, unless it is specified otherwise by me or by the textbook, we are not going to go any further than the 10th place, and that is just one place past the decimal point. Every once in a while, I may ask you to round further out than that. So when we talk about rounding, we're going to look to the number to the right of where we want to round. In this case, it's the number 7. And if that number to the right of where we want to round is a 5 or higher, we're going to round the number that we're looking at up 1 digit. If it is a 4 or lower, we leave it alone or round it down. So in this particular case, I would say 191.2. And this is going to be a milligram dosage because my average adult dose was expressed as milligrams. So let's look at that same scenario with Clark's rule. And this is example 37.2 on textbook page 636. So our scenario in example 37.1 told us that this child weighed 44 pounds. So we're going to take that 44. We're going to divide that by 150. And we're going to multiply it by that adult dose of 650 milligrams. So just like with Young's rule, when we get ready to plug this into our calculator, we're going to do it in one solid equation. So you'll type 44. You'll hit the divide key on your calculator, type in 150, We're not going to hit equals. We're going to hit multiply because that's what our formula calls for next. We're going to type in that 650 milligrams. Then we can hit equals. And it should give you an answer of 190 point, about 4/6, right? So again, if we're going to round this, it would become 190.7 milligrams. I know it's not a huge difference, but you see, these two did not come to the same answer. So that's what we're talking about with Young's rule and Clark's rule, not producing the same result. And I mean, if we're talking about something that does not have a narrow therapeutic index, it's probably not that big a deal. However, if we're talking about a drug where minor dosage adjustments make a big impact on the patient, then this becomes a big deal. That's part of the reason why these have been phased out. Again, however, the national exam still includes these formulas on the test, and that is why we address them and try to make sure that you learn and understand them. So I have a few examples over here off to the side that are slightly out of frame. Let's see if I can get those into the frame for you. There we go. All right. So example number 1 says we have a 3-year-old that's 33 pounds and the average adult dose of the medication would be 50 milligrams. So if we're going to use Young's rule on this particular scenario, then we're going to take 3 because that's how the individual is in years. We're going to set that over 3 plus 12, which equals 15. And we're going to multiply that by that average adult dose, which is 50 milligrams. So 3 in my calculator, 3 divided by 15 times 50 equals that comes to 10 milligrams. Now, if I take that same scenario and we utilize Clark's rule, now we're going to focus on the patient's weight. They weigh 33 pounds. There's 33. Our formula says to set that over 150 before we multiply it to our average adult dose. So your equation would set up looking like this. And then we're going to punch into our calculator 33, hit that divide key, type in 150, hit the multiply key, type in 50, and then you can hit your equal key. And that provides an answer of 11 milligrams. So Clark's rule here says 10 milligrams. Sorry about that. I'm sorry, that Jones rule. Look at me making a mess. Sorry. I apologize. Young's rule said 10 milligram. And Clark's rule said 11. Okay, just for the sake of time, I went ahead and kind of set up the scenario number 2. Here it is with Young's rule. Scenario 2 says we have a 5-year-old that's 43 pounds with an average adult dose of 150 milligram. So I've plugged in my age, 5 years, over 5 years plus 12. That gave me 17. We're going to multiply that by 150. And just before I actually work the math, I went ahead and did the same thing with Clark's rule. We've plugged in the weight in pounds as 43. I've placed that over 150 and I have it set to be multiplied to 150. So if we plug this in our calculator for Young's rule, we have 5, hit that divide key, 17, hit the multiply key, type in 150 and hit equals, and it should give you 44.117. And again, if we're just going to round to this 10th place, this is going to give us 44.1 in this case. Clark's rule, we're going to take that 43, hit the divide key on our calculator, punch in 150, hit multiply, and type in 150. Hit that equal key, and it should give you 42 point a whole bunch of nines. Now, if I were to round this number up, right, it needs to round up. It's going to make this a 0 and push it over to that. So when we round this one up, it actually rounds up to 43 milligrams. I'll tell you now with Miss Jennifer in math, when I make my answer keys, I include exactly what the calculator says. So if it's just a matter of maybe you rounded to the wrong decimal place, you're right there at it, you worked the math right, maybe you just rounded incorrectly, I'm generally going to count you correct. I'm not going to mark you incorrect for that. Give me just a moment to set up for the next problem. Okay, our next one here has a little bit of a twist, so I wanted to address that instead of me setting it up without you seeing what I did. So Young's rule says I'm supposed to use this patient's age expressed as years, but scenario number 3 here has my patient's age listed in months. So when that happens, we can take that number of months, regardless of whatever it is, whether it be 2 months, 3 months, whatever. In this case, it's 18. We're going to divide that by the number of months within a year. So if you divide 18 by 12, it gives you 1.5 years, right? So that's the number that we're going to use when we perform Young's rule calculation here. So now that we've addressed that, we'll put this 1.5 over 1.5 plus 12. That's going to equal 13.5. We're going to multiply that by 1,000. And that is how that equation would set up. For Clark's rule, our patient's weight is still expressed in pounds, so we don't have to do anything special there. We're going to take that 19 pounds. We'll divide it by 150, and then we're going to multiply by that adult dose. In this case was 1,000 milligrams. So let's plug this into our calculator. For Young's rule, we're going to type in 1.5 divided by 13.5 times 1,000. And that should give you right. And if we were going to round to that 10th place, that one spot past the decimal, it just becomes 111.1 milligram. I apologize. I know these decimals don't translate well on the video. There we go. And for Clark's rule, we're going to plug that into our calculator. 19 divided by 150 times 1,000. And that should equal something like that. So if we're going to round to here, this becomes 126.7, right? So that's how we would address that. And now let's look at scenario number 4. Okay, again, so just for the sake of time, I went ahead with scenario number 4. We have a 14-month-old weighing 18 pounds that needs an average adult dose of 750 milligrams. So I've already divided 14 by 12. It gave me 1.16 is what I should utilize for my year. And just like before, we're going to stick with staying rounding to that 10th place, that one spot past that decimal point. So when that is rounded, it becomes 1.2. And again, I apologize if the decimals aren't real clear on the video, but there is a decimal right here. So I've already plugged in for Young's formula. It became 1.2 over 1.2 plus 12, which equals the 13.2. We're going to multiply that by 750. Clark's rule, again, we didn't have to do anything special. This weight was still listed here in pounds. So we listed our weight in pounds, which was 18 over the 150 times 750. So let's plug these numbers into our calculator and see what we get. We get 1.2 divided by 13.2 times 750. And that equals 68.181. So again, I'm going to stick with rounding to that first place past the decimal. In this case, it's going to make it 68.2, right? Because the 8 is higher than 5. So that would be 68.2 milligrams. Let's do the same thing with Clark's rule. We'll take the number 18. We're going to divide by 150 and multiply by 750. And that one should equal 90 milligrams. So quite a difference between 68.2 milligrams and 90 milligrams. Of these two formulas, the one based on weight is generally the more accurate because you can stand two 2-year-olds beside each other, right? And if one's underweight and one's overweight, those dosages should not come out to be the same. So again, I hope this video has helped you out and helped you through the material. But if not, please reach out to me. That is what I'm here for. I hope you have a great day. Bye-bye.